Once again, welcome to A-Level Physics, Cambridge A-Level. Our topic is Dynamic, Part 1. These are some of the graph we learned in kinematics, motion of uniform acceleration. Topic 2, we study different types of motion. So this is uniform acceleration, displacement time graph, velocity time graph, acceleration time graph. Topic 3, we study force causing acceleration and how to calculate this force. Right, some of the Facebook page, you might want to go for resources, Physics AS, where I put my notes, my video, and this is past year paper, workout on PowerPoint before 2020. Same, this is for practical paper 3 before 2020. This is the syllabus, dynamic and understanding of forces for Cambridge, IGCSE or O-level physics or equivalent is assumed. Momentum and Newton's law of motion. Understand that mass is a property of an object that results from change in that receives a change in motion. Yeah, that's how I define for you what is mass. Recall F equals ma and solve problem using it. Understand that acceleration and resultant force are always in the same direction. Acceleration and resultant force in the same direction because they are both vectors. Mass is a scalar. Define and use linear momentum as a product of mass and velocity. Define and use force as rate of change in momentum. That's how you define it. State and apply each of Newton's law of motion. Describe the use of the concept of weight as effect of gravitational field on mass, and recall that the weight of a body is equal to the product of mass and acceleration of free fall. Okay, let's just summarize. 3.1 is momentum and Newton's law of motion. 3.2 is non-uniform motion. It means the acceleration is not uniform. 3.3 is linear momentum and conservation. So under 3.1, we will state Newton's law and application. And we will look at mass and weight. Define mass and weight. Then momentum. Change momentum. Define force. That's the application of force. Under linear momentum and its conservation, we will state the principle of conservation of momentum. Then we look at collisions, elastic and inelastic collision. Right? This one is for simulation for those who are interested to learn using some software. Well, you can get on internet, sometimes for you. MindMap, right? Or can build your own. Okay, 3.1, momentum and Newton's law of motion. Newton's first law of motion. An object at rest will remain at rest. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Right? The object has mass, or we call it inertia. Tendency of the object to stay in a state of rest or motion. So we allow us to define mass as a property of a body which receives change in motion. That's defined by the syllabus. Right? In lower form, we we state as measure of quantity of matter. Right? So it's better to follow what the syllabus say. Right? Newton's first law of motion, I abbreviate short form, NFLOM. Right? First law, Newton's first law of motion. Right? If it's at rest, it remains at rest. This football, resting would be at rest. In motion remains with constant velocity. Condition, no unbalanced force. So if it's kick, then it will continue to move in the air. There's no air resistance, is negligible. Unless it's constrained by a fence. The fence is the force, stopping it, slowing it down. Application of first law in daily life, as a bus or train stationary, person is straight, train starts moving, right? That's the original position. The leg will follow the train, the body will still stays, and the body will still stay as speed of the train increases. It will be slanting more because it is moving further and further away. The leg follow the train. That's the application of first law. The foot follows the motion of the bus while the body is stationary. Okay, so we define mass as a property of a body which receives change in motion. A measure of quantity of matter, a scalar quantity, measures the inertia of a body. It's a constant in any gravitational field. Doesn't matter you take it to the moon, take it to the sun, take it to the star, it will still have the same value. Newton's first law, right? Let's summarize it. Force are balanced on the body. Object at rest means there's no resultant force. Right? That means the velocity is zero. Object in motion, that means the velocity is not zero. So if the velocity is zero, no resultant force acting, or we say sum of forces equals to zero. Right? That's our short form. Object at rest or moving with uniform velocity. If at rest, it will stay at rest or remain at rest. No acceleration, no force. If it's in motion, no acceleration, you stay in motion, same speed and direction. An unbalanced force is a resultant force. Newton's second law of motion, NSLOM. Newton's second law of motion. That's my short form. Collision. In a collision, the amount of damage depends on mass of both cars and the velocity. A fly knocking onto a car would not cause any damage to the car as its mass and velocity are small. A bullet can shatter a windscreen because of its velocity, even though its mass is small. Right? So whether the windscreen will be shattered or not depends on two things, the mass and the velocity. The bullet, even though it has a small mass, is moving at high velocity. So we define a new quantity, take into account of collision momentum, right? Mass of football, velocity of football. Right? We define momentum as mass times velocity. Mathematically, P equals to mv. P is vector, velocity is vector, mass is a scalar. Unit, mass is kilogram, velocity is meter per second. So unit is kilogram meter per second or Newton second. It's a vector quantity as the mass is scalar and velocity is a vector. Vector, vector, scalar. Momentum is in the same direction as velocity. Right? That means direction of momentum follows direction of velocity. What does change of momentum means? Well, that's the initial body with mass m moving velocity u. After some time, it moves velocity v. The change in momentum is your final momentum minus your initial momentum. Right? Take to the right as positive. So in terms of symbol, change in momentum is delta p, final f, initial I. Or we can write change in momentum, mass, right? Take the common factor out, mass, velocity, final velocity minus initial velocity. Right? Second law of motion, let the state memorize it. The rate of change in momentum is proportional to the applied force. That's good enough. Right? And the momentum change takes place in the direction of the force. Right? Change in momentum and direction of the force are in the same direction. Give us a method of finding the magnitude of the resultant force when there is a change in momentum. Same. Initial velocity u, mass of body is m. After a time, it moves velocity v. So force, right? This force that we are saying is called resultant force or unbalanced force. So we can rewrite as change in momentum divided by the time taken for the change. Or in terms of calculus, dp dt. Delta t is the time for the change in momentum. Right? Or we can write as delta p over delta t. Force is defined as the rate of change in momentum. Remember that. That is required by your syllabus, not F equals to ma. Right? So Newton's second law allows us to calculate the force and it defines the force. Force can be visualized as push or pull. Right? This is light, small mass, easy to pull. This heavy mass, it's harder to pull. The force is defined as the rate of change in momentum, right? In terms of symbol or mathematics, delta P over delta T. Remember, it's the resultant force. Or we can take the delta P across there, and then this becomes your F times delta T is called impulse. And impulse is equals to change in momentum. But remember, syllabus, textbook have different, if the textbook have different definition, you cannot follow the textbook. We need to follow what CAIE set as a standard. Because CAIE is the one who will mark your paper. Unit for force is kilogram meter S minus 2 or Newton. Or we use short form capital N. Derivation of the formula F equals to ma. Suppose a force F acting on a body of mass m changes in velocity from u to v. Right? The body has a mass m. There's the body, mass m. Initial speed u acted by a force, and then move a distance, and then the velocity is v. After a certain time, it has a velocity v. The force is acting. This force has not changed. Initially, the time is t1. After t2, the velocity is v. Right? So that is our definition of force. Replacing the change in momentum with m, v, and u. Replacing that change in momentum, m, v, u, You have a delta t. That one is A. The definition of acceleration. So F equals to ma. That's what we get. Where our delta t is t2 minus t1. The time taken for the change of the time interval. Or sometimes we use just time. Right? If you consider as 0, that as t. Now, when the force is in the same direction as the velocity, the momentum increases. Right? Same force, same direction as a change in momentum, then the velocity increases. Body accelerates. Force, same direction as velocity, body accelerates. Force opposite the direction of velocity, it decelerates. Definition of Newton. 1 Newton is the force which acting on a body of mass 1 kilogram produce an acceleration of 1 meter s minus 2. F and A are vector quantities. Direction of F follows direction of A. Okay, in kinematics, we study object acting on by a force. It accelerates. So you should be able to read that this is the initial velocity, this is the final velocity. Right? So this part is uniform acceleration, this part is uniform velocity. So that is the V minus U is change in velocity. So acceleration is the change in velocity over time. Right? A change in velocity over time. Or find it as the gradient of this straight line. Well, if we are required to draw the acceleration time graph, this part is uniform acceleration, it's constant acceleration. This part uniform velocity, so no acceleration. Okay, or we can take this one, AT graph, then it tells us that area is a change in velocity. Area under the acceleration time graph is equals to change in velocity. Right? Examiner can test you anyway. They want to know whether you know how to apply your knowledge. Right? So instead of looking at velocity and change in velocity and acceleration, you can look at momentum time graph. Right? It's the same. So that instead of U and instead of V there, you just multiply by M, that's all. So this initial momentum, this final momentum. And PF minus PI is the change in momentum. Right? Previously, we used velocity for this part. Right? Previously, we used V equals to U plus AT. Now the difference is we multiply through by mass, by M, mass. Right? You just take this to the front, this to the back, and then rewrite that as a final momentum. That's the force. Ma is the force times time. Is the initial momentum. That's the graph. So initial momentum, final momentum for this straight line, equation of this straight line. So F, so for momentum time graph, the force is given by the gradient of the straight line. Okay, so we are drawing the same picture. Previously is acceleration against time. Now it's just force against time. Same thing. Right? This part is constant force. This part is not force. Force is 0. Right? Or as I say, we can rewrite our definition of force. Ft, so F T, F times T is this area under the force time graph. We call that change in momentum. Okay, so there's a definition of force. It's just the gradient. Delta P over T, gradient of this straight line. Okay, so we can take this one, take T across there, we get this equation. Ft, force times time, is area under the graph. Force time graph. Weight. We're just using this formula that we just derived. As the weight, where weight acts at the center of gravity. Right? There's a point called center of gravity, which we'll define later on. Weight is the effect of gravitational field on the mass. Right? The Earth creates a gravitational field. So when you put a mass there, it experiences a weight. When the mass is placed in the Earth's gravitational field, it experiences a weight or force of gravity. Newton's second law of motion gives us, right, from this formula, A is your G. Resultant force in this case is the weight, W. And G varies from place to place. G is the acceleration due to gravity. So weight is the effect of gravitational field on the mass. It's the force of gravity on the mass. It's a vector quantity. So it varies from place to place, depends on the gravitational field strength G in the place. Right? Gravitational field strength and acceleration due to gravity are the same term. Resultant force. Right? We have a car. Thrust is provided by the engine and is in the direction of motion. It's going to the right. So thrust is a force provided by the engine T. And then there's your drag. Drag is the opposing force due to air resistance, air resistance and friction between the tower and the car. When the thrust is greater than the drag, the car accelerates. Right? That's the thrust, that's the drag. So we apply the Newton's second law, F equals to ma. Find the resultant force, we take T minus your D equals to ma. Right? Where m is the mass of the car, a is the acceleration of the car. Okay, show you some factor there. Acceleration is in the direction of the thrust because the thrust is greater than the drag. When the thrust is balanced by the drag, the car moves with uniform velocity. Right? In this case, T equals to D. No acceleration. We call it equilibrium. Acceleration equals to 0. What happens when the force acting on a car is 0? Right? Remember, we are applying it to Newton's second law. Previously, we looked at the first law. For stationary car, right? The car has a mass, it's not 0. Stationary car, final velocity equals inertial velocity equals to 0. Car remains stationary. Yeah, from here, no resultant force, 0. Cross multiply, 0. Right? So V equals to U. Final velocity equals initial velocity. Car remains constant. Right? If the car is moving, velocity U. Right? Car is moving, no resultant force. Take across there, V still equals to U. So the car continue with uniform velocity. Right? It's the same as the first law. So this is Newton's first law of motion. So Newton's first law of motion is a special case of Newton's second law of motion. That means the laws are not independent laws. First law can be obtained from second law. We revisit our projectile motion, object thrown or fired horizontally. Why is it moving that way? Right? That's the path of the projectile or of the cannonball. The weight is pulling it down. The weight is the resultant force pulling it down. It's always the same value, same direction. Cannonball is fired horizontally. Cannonball moves horizontally with uniform velocity u, but is pulled downwards by gravity. This causes the vertical acceleration. The force of gravity, which is the weight, which is the resultant force, pull it downwards. Right? It's always the same direction. So we can see that this is called a parabolic path. So condition for parabolic path, the force is constant. In this case, the force acting is the weight, which is constant, always in the same direction, and magnitude. Right? Constant force, always in the same direction. Cannonball is moving at an angle to the initial velocity. Right? It makes an angle to the initial motion. It makes an angle to the initial motion of the cannonball. Sorry. The cannonball make an angle with the weight. Right? Not vertical. It must be an angle to the weight. It can be thrown upwards there. It can be thrown downwards there. It's still a parabolic path. Right? So in this case, the downward force is the resultant force, which is the weight. Right? In terms of application, why do we have a seatbelt? Airbag plus 3-point belt in car for in car safety. When car collide with another car, the inertia of the driver causes him to continue to move forward. About the head to move forward. You see, because the car stopped for the collision, right? The buttock there will remain with will keep stationary. That's why the head move forward. So the seatbelt restrain the passenger from continuing to move forward when the car brakes suddenly. And what's the purpose of the airbag? Right? They're just applying it there. Formula. Purpose of airbag. Increase the time of impact. Yeah. Doesn't the time increase the time of impact because it's soft to reduce the force on the chest. Increase that, reduce that. Right? Instead of the steering wheel hitting your chest, you have an airbag which is larger, surface area is larger. So spread the force over a larger area, thus the force per unit area would considerably be smaller. Right? If you study later on, pressure is force over area. Right? So the force instead of concentrating on a small area is now spread over a big area. So the force per unit area is now smaller, less injury to the person. Newton's third law of motion. Newton's third law of motion, NTLOM. For every action, there's an equal and opposite reaction. Right? We have wheel there so that there's no reduced friction. So to move backwards, throw the ball forward. That's what you do in space. Action, throw the ball forward, you move. Reaction, you move backwards. Alternative way of expressing it, the push or pull of a body A on body B is always equal but opposite to the push or pull of body of B on A. Right? You have to memorize all this because it's required. Right? Example, this is your string. This is your object A is positively charged. Object B positively charged. You can use a balloon, charge it positive. So there's a repulsive force. Force of B upon A. That's your object A, balloon B. Force of B on A. And this is the force of A on B. It's a repulsive force. Action, one of them is called the action, the other called the reaction. The force of B on A, that one, equals to force of A on B. Same magnitude, but opposite direction. You put a negative sign there, because force is a vector. Right? Another example, action and reaction forces. Right? This is the moon. This is the earth. So this is the force of the earth on the moon, and it acts on the moon. Whereas this is the force of the moon on earth. Right? Moon on earth. It acts on the earth. Right? They occur in pair. Action and reaction force occur in pair. They are equal but in opposite direction. Act on different body. This force act on the earth. This force act on the moon. They are equal. They are opposite to each other. They are of same origin. Previously, gravity is gravitational in origin. This one is electric. Both are electric force. The two bodies are not necessarily in equilibrium. This one repulse. So it's not in equilibrium. It's accelerating away. Other example, action and reaction. The shoe pushes on the ground pushing on the shoe. Right? Earth pulling, man standing on earth, you standing on the earth. Earth pulling on man downwards with a force of gravity, and man pulling on earth with a force of gravity. Right? So these are action and reaction force. Man, earth pulling on man downwards. Man pulling on earth upwards. So these are equal and opposite forces. Common mistake that we make in O level. Force of gravity pull on the book due to the earth. Right? The weight is due to gravity. The force of gravity pulling on by the earth pulling on it's not the table that's pulling on the book. Pull of the earth on the book. Reaction force is table pushing on the book. That's a common mistake. It's wrong. Right? That's why we study at O level, which we in A level we say it's wrong. The reaction force is the book pulling on the earth. That's the earth there. It's not in proportion. There's the earth there. Pulling on the moon, on the book, and the book pulling on the earth. These two are action and reaction forces. Right? Pull of the book on earth. Without the earth, there's no weight. Without the earth, there's no weight there. Right? The traction of the table on the book is very small. Right? Because the table is of lightweight, very small mass. So negligible. There's others. Right? You fill the air, the balloon with air, let go of the air will rush out, and the balloon will shoot outwards there. When the balloon that is filled with air is released, the air pushes downwards while the balloon moves upwards. Example of Newton's third law, firing a pistol, right? Bullet move forward, gun move backwards, pistol move backwards. When the pistol is fired, the bullet move forward, while the gun or the pistol move backwards, right? We call it recoil. Okay, let's try some problem. There are some of the formula that we have learned, and we need to know how to use them. Okay, a car is moving with constant velocity. Resultant force is 0. Show the forces acting on the car. Right? Weight of the car acts from the center of gravity. Right? There's a point there. Center of the body. From the center of gravity where the weight acts. W. T. Thrust is the force the engine acts on the car. Right? So the car engine is somewhere there. So T is the thrust provided by the engine. Then there's your friction between the tire and the road. Right? Or if you prefer, you can call it drag to consider the air resistance also and friction together. Friction opposes motion. So its direction is always opposed to the direction of motion. Then there's the normal reaction. This is the force the ground acts on the car and is normal to the ground. Normal means 90 degrees to the ground, vertically outwards. How are they related? How are the forces related? Right? W equals to N, T equals to F. Right? Or another way of writing it, take the N across there, become 0. Or there's a short form, sum of forces equals 0. That means you have to consider direction. Right? W minus. That means you take positive as ours. Or the equation, take the F across, the small f across there, T minus F equals 0, or sum of forces in the x direction is 0. Positive to the left. Right? It's up to your choice. You can take positive to the right if you want to. It's your matter of choice. Aeroplane moving in constant height and constant velocity. Right? What are the forces acting? Drag, D, right? There's a thrust over the engine due to the wing and airflow across the wing. Then there's a weight acting from center of gravity. Right? The lift will be outwards there. How are the forces related? Right? Drag equals the thrust. It is constant velocity, constant height. Weight equals to your lift. Or forces outward equals to forces downwards. Forces to the right equals to forces to the left. Right? The aeroplane is in equilibrium. Holding a load. Holding a load. Right? Then hold a rope there. T is the tension. W is the weight of the load. Right? Tension is the force the rope acts on the load. Right? So that's your tension. That's your weight. That's the center of gravity. So W equals to tension if the barrel is not moving or if the load is not moving. What's the purpose of pulley? To change direction of the force. Right? Instead of pulling it upwards there, you can pull it downwards there. So if the weight of the barrel is 5 Newton, the man is pulling with 5 Newton. If the barrel is held stationary or moving with constant velocity. What happened when the rope is cut? What happened to the load? The load ascends downwards. Nothing to support it anymore. What's the resultant force? Because the weight of the load, that's the resultant force. Acceleration is the acceleration due to gravity, G. Accelerating car. Pressure T is a thrust provided the engine in the direction of the motion. Drag opposes the force and is due to air resistance and friction between the road and the tires. When the thrust is greater than the drag, the car accelerates. Right? T greater than D, it accelerates forward. F equals to ma, T equals to T minus A, D equals to ma. Right? Acceleration direction of the thrust. When the thrust is balanced by the drag, T equals to D, then the car moves with constant velocity. Right? Usually you can increase the drag and increase the acceleration, then increase the velocity. At certain stage, right, the drag will increase with velocity. At certain stage, you cannot accelerate anymore when the thrust equals to the drag. Then the car is moving with constant velocity, which we'll study later on in this topic. Right? This is called equilibrium. T equals to D. Braking a car. Resultant force is normal zero now. It's moving. So you brake the car, it means you're trying to stop it. The direction of motion, the red arrow. Friction is opposite direction. Right? Friction opposes motion. A braking car slows the shock to a stop, it decelerates. Friction is the unbalanced force in this case, and the car decelerates to a stop. For a smooth surface, no friction. For instance, on ice, the car will continue to move with constant speed. Right? This is a trapezium. Area of trapezium is just your half. You add the parallel sides A and B, and then you times H. Right? A plus B half H is your vertical line. Okay, what does the area under the force time graph represent? The graph shows the force acting on the body varies with time. Right? That's the formula that we are using. So delta P equals to F. Take your delta T across there. Right? And use delta T of T. Depending on how you define your T. So this is F times T. F times T is the area under the graph. It's force times time. Change in momentum. So area under the graph is the change in momentum or impulse. Assuming the body is moving in a straight line, by how much does its momentum change in 6 seconds? Okay, so we just find area under the graph solution, change in momentum, area under the graph, that rectangle, 2 times 2, 2 times 2, then area of this trapezium, that's your 2 plus your 6, that's your vertical height, 6 minus 2 is 4, okay, calculate out 20 Newton second. Okay, know how to play with formula. If you use calculus, that's how you calculate. Okay, that's the formula that we use. We just transfer the P across there, change in momentum is equal to impulse or area under the graph. Okay, I think that's the end of the lesson. Let me leave you with some work to do, some work to try out, and we will discuss it in the next lesson. Next lesson will be to solve the problem, and then we go to weightlessness. Right? Try this equation. Try this question. 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 Okay, so that's the end of our topic. We'll see you in the next topic.